this morning we heard some very good talks on evolution of non-destructive testing techniques, ultrasonics, computer radiography. Mike gave a presentation on how some codes are now adopting some of the new NDT techniques, specifically phased array and auto UT. What I'd like to talk about is another enhancement which could improve productivity of your non-destructive testing inspection, specifically workflow-guided inspection. I'd like to apply it in this case to ultrasonic inspection of welds. On an overall worldwide basis, non-destructive testing of welds accounts for about 40% of the global NDT applications. And as you know, typically radiography is used, or ultrasonics, manual ultrasonic weld inspection. Both techniques have been around forever, well established, and have started to evolve in terms of radiography into the computed radiography that was discussed this morning, and in terms of ultrasonic inspection into phased array and more of the more automated techniques. At the same time, there is an ongoing transition from radiographic to ultrasonic weld inspection for some specific applications. The term that has been used over the last few years is phased array in lieu of radiography. There are some advantages, obviously. I mean, ultrasonics now, with the advanced techniques, can now give you a visual image of the quality of the actual volume that's going to be inspected. And at the same time, by transitioning to ultrasonics, you eliminate some of the constraints or challenges with a radiography. Things such as, having to barricade off the area, obviously, while you're doing the radiographic exposure, and some challenges with disposal of the radiographic consumables. At the same time, you're also looking at other advantages of ultrasonics. Now you have an easy to interpret image, image versus the signal interpretation, easy report generation. And I'd like to really focus on the third bullet down there. There is an ongoing trend in the industry with a limitation or limited availability of NDT experts. Specifically, the pool of the advanced NDT experts is really decreasing over time. And that's a trend we're seeing not only here in the US, but on a global basis. There are other aspects to consider. Obviously, the more skilled a person is, the more costly they are to use for a specific inspection process. You kind of wrap that in too with a lot of the advanced techniques. You do need this highly skilled or expert NDT person to perform the inspection operation. In order to kind of address a lot of those concerns, I'd like to kind of walk through a typical workflow-guided ultrasonic weld inspection. The key thing to keep in mind that with a workflow-guided, or also called menu-directed inspection, it ensures you have a controlled and documented inspection process. As you can see, in this case, we've broken up the inspection process, or the workflow-guided process, into 5 specific steps, from creation of the inspection plan, through the actual data collection, the analysis of the data, the reporting, and the archiving. So what I'd like to do now is walk through these 5 specific steps one by one. In terms of creation of the inspection plan, there are a number of tools commercially available that can kind of walk you through the different ray diagrams and so forth to ensure you have sufficient coverage of the actual weld. There are some workflow tools that, by inputting information based upon the code requirements, the dimensions of the component to be inspected, in this case a pipe, weld geometry characteristics, and the actual specifications of your preferred inspection product, such as the probe characteristics or the instrumentation characteristics, you can generate an inspection or scan plan. Now keep in mind, that after the generation of the scan plan, you do need the responsible expert, typically a level 3, to ensure that the scan plan does meet all of the appropriate code requirements. The next step, obviously, is the inspection of the component. With a menu-guided inspection, you can be sure that it walks through the requirements of the inspection, specifies the characteristics of the probe down to the specific part number, relates it to the actual code which is being involved with the specific inspection, specifies the probe positioning in terms of the coverage that you're looking for and so forth. So it walks the inspector through all of the steps. I'm going to be showing an animation a few slides down, which kind of makes it a little bit more evident in terms of when the inspector is on site, how it aids the inspector ensuring that he is performing the inspection as specified. The third step, obviously, is the analysis of the actual information which is collected, the data. On-site or remotely, has different advantages. Sometimes they are required for immediate on-site determination and disposition of the product. You do have some advantages if you can access somebody off-site or remotely, obviously, to help you make a determination. Have to have specific analysis tools in order to characterize the indication, and a common analysis platform that allows you perhaps to compare it to other NDE data. I'd like to talk about a platform called DICONDE, which was mentioned in the computer radiography talk this morning. The nice thing about DICONDE is it is an open architecture, which means it's available to everybody, obviously. It stands for Digital Imaging and Communication in NDE. It was taken from DICOM, which is a medical data architecture. It is a ASTM standard, and again, it's essentially a single platform that allows you to analyze, report, archive, and share non-destructive testing data. For example, here we're looking at radiographic, phased array, UT, and tough data of the same component. And again, you can see the indications on the screen there, so it could perhaps provide a verification of another technique. But the real beauty is you can pull all the data in to the same database now and allow you to do this type of comparison. You can use common tools, a common interface, irregardless of the type of non-destructive testing modality that you're using. The fourth step is data reporting. Pretty straightforward, obviously, to allow you to have an option of using standard or template reports, or of course to customize to your specific requirements. And the fifth step is archiving or collecting the data. Especially with phased array, UT, and computed radiography, these are fairly large files. And you have to have some type of capability to, of course, either store, on site on a PC perhaps, or to send them to some kind of central server. So right now the inspector is saying, I've collected the data. I'm going to hit a little checkbox here to tell everybody that I've appropriately collected all of the data. And now he has a chance to do some analysis on site, or he can send it remotely to his expert and let the expert go ahead and do some analysis for him. You can do real-time data transfer, or just stick it on a USB stick, whatever is practical in the specific application that you're looking at. So the inspector has taken a scan plan, he's been guided through the inspection, he's collected the data, And in this case now, he's sending it remotely to his expert to actually look at the data and to do the data analysis. Again, as we discussed earlier, certain tools should be available in order for the analysis to be performed. In this case, line straightening and so forth. You can set up a defect table and so forth. Same thing with the phased array inspection. Again, so we're kind of at the analysis and reporting process here, and now we're at the archiving. And then the data goes all over the world. So let me go back to the presentation. So we kind of walked through, what the process is. Let's talk about what the value of the menu-guided inspection is, though. And it really depends upon which category the operation falls in. I mean, there's different value for an asset owner, for example, than for a fabricator, an engineering contractor, or an inspection service provider. Starting with the benefits for an asset owner, it obviously optimizes the use of their level 2s and their level 3s. And it can actually increase the capacity of perhaps other folks who are being trained within the organization. It is a simple menu-driven workflow, so it avoids a lot of perhaps some of the in-the-field confusion on what the next step is in the operation. And then using a common software application and database allows you to really share, between different NDT modalities, in this case, ultrasonics and radiography. Fabricators, it can improve the productivity by optimizing their inspector pool, and because it's ultrasonics instead of radiography, by reducing the radiographic constraints as we talked about previously. Engineering contractors, it's all about faster project turnaround, which leads to, a faster return on final receivables and so forth. Again, an integrated workflow with documented reporting and so forth. Perhaps increased document management and traceability. And finally, for inspection service providers and so forth, this common database with ultrasonic and radiographic data using common interface, graphical user interface, so the different features are in the same place on the screen, irregardless of if you're doing an examination or analysis of ultrasonics or radiography. So really, depending upon which of those 4 areas you fall into, a workflow guided inspection, a menu directed inspection, could offer you some significant advantages. In summary, again, we walked through workflow guided inspection. We talked about, the ongoing radiography to phased array inspection for some weld inspections. In fact, the next speaker is going to be focusing on that and reviewing that with you. Talked about how workflow guided inspection ensures a controlled and documented inspection. Talked about DICONDE open architecture to allow fast and easy sharing of NDT data. And then we also talked about the workflow benefits or the value to the different categories of folks who obviously are considering it. And that finishes my presentation. Thanks for your attention, and I'll field questions.